Hello, my name is Yusha Bey. I'm one of the process engineers for the CNM2 clean room. I'm here to show the basic operation of our Brewer scientific spin coaters. So our spin coaters are kept in an exhausted enclosure. Our spin coaters can handle pieces, can handle 4-inch wafers, 6-inch wafers. We'll spin coat, you have your positive photoresist, you have your negative photoresist like SU8. Some people even spin coat PDMS. One of our spin coaters also has an integrated hot plate. We can do spin speeds up, going back to spin coater application, we can go up to like 12,000 RPMs. And I think we have a ramp rate of like 4,000 or 5,000 RPMs, but something that is something that most people won't really use. So we can really meet the needs of our diverse membership. So jumping into the spin coater here, I'm going to open this little sash. Well, really your first step will be to go to Badger and log on to the tools. So the IDs of these tools is Brewer 1 on the right, we got Brewer 2 on the left. Brewer 2 has a hot plate. That's literally the only difference between these tools. So we're logged in on Badger, we check the history, we check the maintenance, make sure everything's okay, that vacuum is good, or that no one reported any issues with the tool, or that the tool is not down for maintenance. So when we use the touchscreen, so this is a touchscreen, so this is a more modern tool. Okay, so to interface with the tool, to operate it, it has a touchscreen computer. Whenever we operate this tool, we always want to use the stylus that you can be found right here on this Velcro. So I'm going to go ahead and I'm going to back out. I'm going to log out completely. Show you what that looks like. So you may come to a screen like this. There may be a facility power outage. You come here, you'll use the main power switch to turn back on. It'll take you to the desktop. You really have only one option, which is the CEEX. CEE standing for Cost Effective Equipment. So we just click on that, just double tap. Sometimes I have to be patient. There we go. All right, now we have our application open, and this is the model of this. It's the Model 200 CBX. So we want to log in. Our login is just USER. I think I got that right. Login failed. USER. Enter. Okay, so now we're in. So first thing I want to show you is just how to operate this hot plate. So I guess some notes about the hot plate. It was designed for uniformity. Designed to be very uniform. To accomplish that uniformity, the aluminum slab is pretty thick. What this thickness does is, the compromise for that uniformity is that it takes some time to heat to reach your set point. So some lab members will come in like an hour or even an hour or two before they need to actually do their lithography, just to make sure the hot plate has reached the set point. So to run our hot plate, we just go to this second little dialog box, just run thermal process. Right. So you want to go to load. And here is pretty much every imaginable temperature that you would come across in practice for soft bakes, for hard bakes, post-exposure bakes. It's all here. Let's go ahead and just pick one, 95C 2-hour contact. Press enter. It's loaded. So now we want to press start process. So sometimes you'll pick a recipe that's not in the range of where the hot plate is now. So let's go ahead and pick something that's a little bit outside of range. Let's do like a 110. Oops. So you'll get this warning, hot plate not in range. Just proceed. Press yes. So in the very unlikely event that you cannot find a recipe you want 111C. First thing you do is load a recipe, edit a recipe. So here you can pick, you can put it in 111. You can change your time. Big note is that even after that time has elapsed, the hot plate will remain at the last temperature that it was set for. So it could be like 1 minute or 2 minutes. It will just stay there once the recipe time has elapsed. Also the bake method, really you only have contact. Unfortunately, we do not have vacuum. We do not have a proximity option. Then to save, so you pretty much just save as, pretty much like all Windows operating systems here. 111. Go back. Then you just go back into that database, find your 111C, abort the previous process, start the new one. And that's about it. Very straightforward, very intuitive. So now, moving on, we're gonna back out of this to that main menu. Press back. Now for the more interesting part, we're gonna run a spin process. Okay, so I'm gonna go ahead and I'm gonna open the lid. When you come here, the foil should always be fresh, new foil, no photoresist in there. If you do happen to find that there is photoresist, please report that so we can remind the lab member that we will always change our foil, always change foil after every use. That's probably the most important part of using the spin coater. So, first thing you want to do here, just like the previous, when running a thermal process, we want to load a recipe. Go to load. We're going to pick a recipe, 146A. About 146A, 3K RPM. Recipe loaded. Say that you want to verify your recipe. Say that you want to double check. Want to go in here. You see if we can set our velocity, final velocity. We can set our ramp rate. We can set our time. And we have no dispense option. This is all manual dispense with a pipette. If you change anything, just like with that previous recipe for the thermal process, you just press save. Change the name based on the parameters that you have in there. Press enter. Now it's saved. Then go back. One big note is that whenever you create those recipes, just like in the previous menu for the thermal process, it will not load automatically. Like you always have to go back into the database and find the new recipe you created. One little annoying thing, but it's not a big deal. Okay, recipe loaded. Next step is that we want to load our wafer chuck. If we pan the camera hither, have several options. You can accommodate 6-inch wafers, accommodate 4-inch wafers, and even smaller pieces. We have lab members that are currently processing 3x3 millimeter diamond, which is very challenging, but they were able to figure it out. Yeah, they do that part 3x3 millimeter at 12,000 RPM to reduce the instance of their edge bead. So we're going to do just a standard one. We're going to use a 4-inch wafer holder, which is this one. We also need a little hex screw to tighten it down to the spindle. And we also need a hex wrench. This wrench should always be over here. We also need a centering tool for our wafer. Okay, so now to load the chuck. I'm going to briefly put the mic down just to show what that looks like. Perhaps I need to bring the microphone back. So our spindle right here has a post, which we call a key. Also, our chuck is keyed as well. There's a little slot in there. So we want to make sure that that slot mates with that post. So you do the best you can. Boom, it's on there. Next, we take our screw, use our hex wrench, and we'll lock it down to the spindle. So we do not need insane tension here because everything is held down by vacuum. You know, like that's sufficient. Just make sure that the screw is lower than the chuck so the wafer can be flush with the chuck. And then next, we put our wafer on. So here's where, I need both my hands because we're going to do leveling, or sorry, not leveling, but we need to do centering of the wafer. So it may have been difficult to see, but I can demonstrate out here. When centering that wafer, you have this little lip on the centering tool that goes down below that, and then your wafer, the edge of your wafer is flush against this upper portion of the centering tool. And that allows you to accomplish nearly perfect centering. So to verify that we centered our wafer correctly, see that you have this big option of start centering. Do that. It'll slowly rotate the wafer so you can just see if there's any wobble. If there is, you'll just come back with your centering tool and make the adjustment. And then you see that the center option has now moved over to the right side. So now you can just keep recentering if you need to make more adjustments. And also you see release button hasn't really changed. Okay, so after that, we will dispense our adhesion promoter, HMDS, or our photoresist, or both. Not at the same time, but one after the other. We dispense it on the wafer. We close the lid. Now we see that lid closed. That interlock needs to be on in order for it to be able to spin anything. Once the lid is closed, we just press start process. Here we see our spin speed, we see our duration, we see which step we're on as well. All right, and that's about it. See that the vacuum automatically releases on the wafer once the process is done. We open the lid and retrieve our wafer. So now you'll have a bunch of photoresist everywhere, or you'd process your wafer. So one big key is that we don't want to process 10 wafers in a row and have a huge pool of photoresist in here. Our exhaust is pretty good. However, it's not sufficient enough to pull the fumes out from that. So what we want to do is, like, if you had to do a large batch of wafers, 25 wafers, we request that you do 3 at a time, change the foil after every 3 4-inch wafers, and after every 1 6-inch wafer, because it's just a lot of photoresist in a bowl. To do that, we dispose of our lithography resist, our lithography waste, tech wipes, our pipettes, our gloves. Oh yeah, that's a big note there. We use this tool with 2 sets of gloves. Actually, if the camera turns around, you can see that there's our extra pair of gloves that we'll use whenever we're doing photolithography. We'll double glove. So yeah, if your gloves have photoresist on them, they'll all go into a large Ziploc bag. Your foil will go in a Ziploc bag. And then whenever you're changing that foil out, you want to make sure that everything stays within the exhausted enclosure. Do not bring the bowl out because it's a very hazardous chemical. And then once you change that foil, you put it in here, you close it up, and it just goes into the general waste bin. any general waste bin in the facility, but that's the most convenient. To reline this, let me just pull this out. Pretty straightforward. So let's say we pull that out. We want to reline it. The camera can pan over there. We have our new foil over there. Pretty much just pull out a sheet of foil and just one sheet of foil will work, and you just push it right down and you punch a hole for the spindle. Very important that we do that after every use, and then when you leave the tool, the idle state is a fresh foil. And also be careful not to put too much foil on the edges, because that can actually interfere with the lid sensor reading that the lid is closed. You want to just sometimes have this foil be a little bit below it, or have like a very thin layer so the lid can still close. And that's all I have for you. Thank you for attending this training.